Welcome guys, welcome back to the channel. Hope you are doing extremely well, and this is your very own mass coder this side. So welcome to yet another practice problem of the linked list series, right? We are going to discuss the 82nd problem from the lead code, right, which is remove duplicates from sorted list 2. The problem is actually very simple. Initially when we were discussing or removing duplicates from sorted list, what does that mean? We were doing something like this. So 1 was occurring once, 2 was occurring once, 3 was occurring once. You can see 3 is occurring twice here, but in the answer linked list you were using only one of them. 4 was occurring here except from the 3, and 5 was occurring here, right? But now the question demands us that if a value is duplicate in the original linked list, like that is, you can see 3 is occurring twice here and 4 is occurring 3 times here, I do not have to use any value. That is, my answer linked list should look something like 1 connected to 2 connected to 5. I should properly discard 3 and 4. I should not even take one value from that. Okay, so watching this video, which has already been discussed in the playlist, is a prerequisite for this video. If you will watch this video and then come here, the concepts are gonna be crystal clear, right? So that's all I can request you for, that please watch this video first and then come to this video. You will get more grasp on the topic. Now, how to solve the problem? How to solve the problem? So this is actually converting a linked list, right? This is actually a problem of subtype converting a linked list, forming a new linked list. Forming a new linked list, to be precise, forming a new linked list, right? So what is our approach? Dummy. We will use the dummy approach. We will create a dummy node, that is -1 is created here, which is a dummy node. You can use any other value also. A is assigned here for the traversals, right? So suppose this is my linked list, this is my input linked list. What will I do? I will keep my temp here and traverse. Initially when we were doing it for the first case, that is this one case, what we did was we compared the temp value with the A value, and if they were same, we did not add that value into the answer linked list, right? But now the approach is going to be slightly different, not more difficult. Please try to focus. It is a 5-minute topic only. So A is here, my temp is here. Now, instead of comparing temp with the A value, I will compare temp with the next value. So 1 is not equals to 2. That means it is a unique value. So connect it. A is here, A comes here, temp move forward, and the connection breaks. For those of you who have not followed the playlist and wondering how did that happen, so the steps are mentioned like this. A next equals to temp. A then comes to its next one. Temp moves to its next one. Temp equals to temp next. And A next equals to null. For those of you who have followed the playlist, I hope that was clear to you without saying, because these steps have been used in many videos in the playlist. So you should have been understood them up till now, right? Okay, again comparing temp with the next value, that is 2 with the 3. It is also not equal. That means 2 is also a unique node. So attach it. This made a connection. A comes here, temp move forward, and the connection break. Temp move forward. 3. Now 3 when compared with its next value, you can see 3 is equal to 3. That is, it is not unique. And whenever there is not a unique node, I have to discard this one also and this one also. I do not have to take any one of them. How will I do it? How will I do it? So you can see that there are 2 nodes only right here. There are only 2 nodes. So I can easily say that switch to 4. But in some test cases, it might be the case that it is looking something like this. 3 connected to 3 connected to 3 connected to 3, and temp lies here. Now you have to see that I have to discard all the 4 of them, and because the linked list is sorted, all these 4 will lie in the next fashion only. That is, there will be no gap here, right? Because the linked list is sorted. So how should I proceed? The approach is simple. I have to discard all of them, and my answer is depending upon the length of the patch. So first point is discard all of them, and second point is that my answer, that is discarding, is dependent on length of patch. So whenever the second points come, I only recommend loop. That is, up till and unless this value is in the node, discard that node. That is, keep a value x here up till and unless x value is equal to temp value. discard, that is x will come here, then again compare. Suppose there is a node 5 here, x, as soon as x comes here, I will say that 5 is not equal to 3, that is a patch has been passed, and then I will discard this patch. I can either delete it or do anything else I want to do, and I will say temp comes here. I will say temp comes here, as simple as that. So what will I do? I will assign x here, I will assign x here, I will assign x here, and see 4 is not equal to 3, that is temp comes here. Now again 4 is equals to 4, that means x, again x comes here, x comes here, x comes here, x comes here. Again 5 is not equals to 4, that means 5 is not equals to 4, that means temp will come here. And now I can see that 5 does not have a next, 5 does not have a next, so it is for sure that 5 is a unique value. So connect 2 with 5, connect 2 with 5, right? A will come here, temp will move towards null, and this is already null, so it will again be null only, right? And now you can see the linked list has been made. The linked list, answer linked list is looking something like -1, connected to 1, connected to 2, connected to 5. This is of course the dummy node which can be deleted easily using 3 steps. That is, head is here, delete the dummy, return the head. Answer is here, 1, 2, 5. That is what we wanted, right? That is what we wanted. So let us write the pseudocode really fast because I think the approach is clear to you. What is our approach? Dummy node A and temp assigned. Now what you will do? You will say while my temp is not null. While my temp is not null. The first condition is if temp next. First check if there is temp next. For suppose when your temp was at 5, you could not have accessed the data of the null node. It will give you a segmentation fault. So what will I do? I will first check if temp does contain next. Then only check the value. So if temp next and temp next value equals to the current temp value, that means I have found a duplicate value. That means x equals to temp while x and x value equals to temp value. What will you do? You will say x equals to x next, x equals to x next, and whenever the inner loop finishes, just assign that temp to x, assign that temp to x. That's all you have to do right now. Okay, so moving on, what will you do in the else case? That is that node is not the duplicate value, then assign the 4 steps. That is a next equals to temp, a equals to a next, temp equals to temp next, and a next equals to null, a next equals to null. As simple as that. I don't think that there is any problem here, and then remove dummy and return answer, that's all. As simple as that. There is no complication here. I don't think that this is any more problematic than any of the question we have discussed in the playlist. So let us move to the answer now, let us move to the code now. Here you can see the coding section. Let us just start writing the code, but before it, please subscribe to my channel and hit the like button as it really motivates me. Moving on, list node star temp equals to head star dummy equals to new list node with value -1. Then make a list node star a assigned to dummy. So initialize all of them. While my temp is not null, what will you do? If my temp has a next which is not equal to null and the values are equal, that is if temp next value equals to temp value temp value, that is a duplicate node is present. Simply list node star x equals to temp while x and x value equals to temp value, just keep traversing, that is x equals to x next. And after this loop finishes, temp equals to x. After this loop finishes, temp equals to x. In the else case, that is a non-duplicate node is present, what will you do? You will say a next equals to temp. That only same story, right? A equals to a next, temp equals to temp next, a next equals to null, a next equals to null. And now at last you will just remove the dummy node, that is head equals to dummy next, delete dummy, and this is single d here, and return your head, return the head. As simple as that. Now many of you will be asking that we are not actually deleting the code, actually deleting the nodes. Yes, that is also possible, when you are traversing, you can actually delete the nodes. It is not a quite problem, but it is getting accepted as usual only. So I'm not writing it. You can delete them. There is no problem. And the second thing I want to say, what is the time complexity, guys? So you can see the time complexity is O of n. One might consider that there is an inner loop also. That doesn't care. Why? Because I'm traversing only forward. No node is getting traversed twice. That means the time complexity is O of n. And let us try to run it. Hope it will run fine. Should not give any error, I guess. It is getting accepted for the sample test cases. Let's hope it works for the submit test cases also. And it is getting accepted. So thank you for watching. Hope you liked the video. Hope you were able to understand the concept. And we'll meet in the next video. Till then, stay tuned and keep coding. And those of you who are new here, do not forget to subscribe. Thank you. Have a nice day.